Okay, hello and welcome everyone. So I'm going to do a walkthrough of some exam questions here. So, all right, on this exam we've got multiple choice and then we've got some short answer. I'll just go over the multiple choice first. I'll talk through the intuition and then I'll do some of the short answer questions. Or I'll do all the short answer questions. Okay, so the marketing individuals at Ben & Jerry's Ice Cream Company believe if they lower the price of their Cherry Garcia flavor ice cream by 25%, the quantity demanded will increase by 5%. If they are correct in their belief, then which is true? Oh, look, here I've got my Cherry Garcia. Cool. So anyway, that was not planned. So anyway, which of the following is correct? The demand for Cherry Garcia is price elastic. Their total revenue from Cherry Garcia will increase if they lower the price. The demand from Cherry Garcia is income elastic, or their total revenue from Cherry Garcia will decrease if they lower the price. Okay, so we have to go and look at the data we've been given. And essentially, we want to look and recognize that we have a larger change in price than change in quantity. So my comment that change in price is bigger than the change in quantity, that tells us the demand must be inelastic. If you were to actually calculate, literally applying the definition of percentage of price elasticity of demand, which is percentage change in quantity divided by percentage change in price, you'll get a number that's between 0 and 1 in absolute value. Right? You'd get 5 over 25, so you get, 0.2. So this tells us that demand is inelastic. We know if demand is inelastic, if you raise the price, you will increase revenue. If you lower the price, you'll decrease revenue. So the answer must be D. Okay, the closer the substitutes are for a good, the more elastic is demand. This is actually one of our key determinants of elasticity. We expect that demand is going to be more elastic, more responsive to price, the more options consumers have. So the closer are the substitutes, the better and more available are the substitutes, the more elastic is demand. Number 3, if a country opens up to trade and becomes an exporter of wheat, in the wheat market, consumer surplus will blank, producer surplus will blank, and total surplus will blank. Okay, so if we export wheat, it must be the case that that country would have a comparative advantage in wheat. And so their producers are going to be able to produce at a lower opportunity cost than the rest of the world. By exporting, they're going to find additional buyers standing ready to purchase their wheat. And so we're expecting export should be a situation that's going to increase well-being for producers. It's going to be at the detriment of consumers because by exporting, you are bypassing domestic consumers, and instead you're selling those units to foreign consumers. But as a whole, we expect the winners will win more than the losers lose. So free trade is overall good. So we're expecting total surplus will rise. Okay, so the answer is, in the wheat market, consumer surplus will decrease because they're losing, because rather than consuming domestically, those units of wheat are sold at a higher price abroad. Producer surplus rises because of exactly that reason. And then total surplus overall rises because the winners win more than losers lose with free trade. Number 4, when the principle of comparative advantage is used to guide trade, then a country specializes in producing only goods with the lowest opportunity cost. This just follows from definition of comparative advantage. You want to produce goods that have the lowest opportunity costs. Number 5, which of the following is plausibly consistent with an increase in the market price of electricity and an increase in the quantity of electricity sold? Okay, so the first thing we have to do is we have to figure out what is it that's like going to describe this effect. We want something that's going to make the equilibrium price rise and the equilibrium price or equilibrium quantity rise. If you're thinking about that, it's got to be an increase in demand, right? When we get an increase in demand, we'd get a higher price and we get a higher quantity. And so I say the overall demand increase must dominate any supply effects that we see below. Okay, so the first one, the population increases, demand increase. The price of coal used to produce electricity falls. That'd be a increase in supply, decrease in the price of an important input, increase in supply. However, it's perfectly consistent, which is plausibly consistent. It's plausibly consistent. The demand effect swamps out the supply effect, so it could be I. Okay, what about 2? Many nuclear power plants used to produce electricity are decommissioned and shut down. That's going to be a decrease in supply of electricity. That's going to tend towards driving up price and lowering quantity. Well, we want price to rise, but we want quantity to rise. So it can't be 2. 3, there's a decrease in the cost of producing hydroelectric power plants. All right, so it should be an increase in supply because there's going to be a decrease in the cost of an important input. And so this would be an increase in supply that would drive down price and up quantity. So it can't be 3. 4, the price of aluminum used in production of windmills rises. So it's going to raise the price of an important input. It's going to decrease the supply. Okay, so we're going to leftward shift to supply, decrease in supply. The price of gasoline used to drive gas-powered vehicles rises. So people are going to swap away from gasoline. They're going to purchase the complement, like Tesla vehicles that run on electricity. It's going to be an increase in demand for electricity. And so in both 4 and in 1, we have an increase in demand that could plausibly swamp out a change in supply. So the answer here is 1 and 4 only. Only 1 and 4 are going to be plausibly consistent with the overall outcome of the market price of electricity rising and market quantity of electricity rising. Number 6, if a subsidy is applied to buyers in a market with inelastic demand, I want to go over my comment, and elastic supply. Okay, inelastic demand, you want to draw a relatively steep demand curve. Elastic supply, relatively flat supply curve. This is talking about a subsidy. Remember, a subsidy is going to be kind of the reverse of a tax. So we'd think of a subsidy just like we would tax incidents. So what's going to happen? Well, the inelastic side, the steeper side, is going to bear the economic burden of a tax and receives the benefits from a subsidy. Like a subsidy is just a negative tax. And so we'd say consumers would receive most of the economic gains from the subsidy because demand is more inelastic. Okay, suppose you were to observe the equilibrium price of organic blueberries has fallen, equilibrium quantity of organic blueberries has risen. Holding other things constant, which of the following are plausibly consistent with the observation? Okay, before we go any further, we are looking for a situation where the equilibrium price falls and the equilibrium quantity rises. So in order to explain that, we need to have a dominant supply shift. So whatever's going to happen has to be the case that we have an increase in supply. It's going to swamp any demand effect because we need for quantity to rise, but for price to fall. Okay, now the rest of this is just telling us how to interpret the information below. So we're assuming organic blueberries are a normal good, which means if income rises, demand increases. If the income falls, demand decreases. Consumers regard conventional blueberries to be a substitute for organic blueberries. Okay, so we think about how substitutes are related. Regard strawberries to be a complement to blueberries. Okay, so think about how complements are related. Right, so we need price to fall, quantity to rise. So we need supply increase to dominate any possible demand effect. Okay, so suppose the media reports some study finding health gains from eating organic fruit are overstated, and there's excellent weather in blueberry growing regions that create an unusually large harvest and nothing else changes. Well, okay, so this is going to decrease demand for organic strawberries or blueberries, and people are going to substitute for conventional strawberries. We get a decrease in demand from this part, right? So decrease in demand from the first part, but this excellent weather is going to cause an increase in supply, which is exactly what we need. We need an increase in supply, so it could be number 1. Okay, number 2, the price of strawberries falls. Okay, decrease in the price of a complement, because I've told us that strawberries are a complement to blueberries. Eat these together. So if the price of strawberries falls, we increase demand for blueberries. Okay, great. Oops, I drew this direction the wrong way. I drew my arrow. This direction needs to be an increase, but the supply effect makes it not to anyway. So let's see, the wages of workers harvesting blueberries rises. That's going to be a decrease in supply. That decrease of supply isn't going to allow us to get the overall increase in quantity and decrease in price that we're looking for. So it's not 2. This arrow needs to be going up because we're thinking of strawberries as a complement to blueberries. All right. Consumer incomes increase. We said we're regarding blueberries to be a normal good. So this should increase demand. And that doesn't do the increase in supply that we're looking for. So actually, of these, only 1 could be correct, I, which is giving us an increase in supply that can swamp out this decrease in demand effect. Okay. All right, suppose the government increases the minimum wage. In the market for labor, the resulting increase in wage reflects primarily, well, remember, the wage is just the price of labor. So here we have a change in price. If you have a change in price, you can only have a change in quantity. You can't have a shift. So we can immediately discount anything that involves shifts. It can't be A or B because these involve shifts. So now we're looking at either C or D. Actually, we're discounting, it can't be E either. So we're looking for a movement along either the supply or demand curve. For this, we need to understand how price controls work. Remember, price controls are going to create this situation where there's either going to be a shortage or a surplus. The minimum wage is going to be a binding price floor if it's above the equilibrium, which means we're going to get a larger quantity supplied than quantity demanded. It's going to be a surplus. We call it surplus unemployment. But what's going to end up happening is what's driving the quantity in the market quantity traded is going to be where the minimum wage is. So what's happening is the actual quantity of workers employed is going to go from QT1 to QT2. That's a movement up and along the demand curve. And so it's got to be D. Okay, suppose you want to show the rent controls have a large impact on the number of families who can find apartments. Helps your argument if you can show in the market for apartments, supply is elastic. Why? We want to show that the price change is going to happen will cause a big response in quantity supplied. Remember, just like the minimum wage question, rent controls are just going to affect the change in price. It's not going to shift the curve, so we can only get a change in quantity, which is the relevant quantity for that market, for the apartments that people can find, right? We're worried about the number of apartments that can be found. Well, that's going to be QT. That's the quantity supplied. And to get a big change in quantity supplied, we need a relatively elastic supply curve. Okay. Suppose the demand for coffee is very elastic, so I'm going to draw a nearly flat demand curve. Supply is very inelastic, so I'm going to draw a very inelastic, very steep supply curve. Which causes the greatest change in quantity consumed? To get the biggest change in quantity consumed now, we want something that's going to give us, for a given price change, we want to get a large change in quantity demanded, or for a given whatever is going to happen, we're looking for a large change in quantity demanded. Well, to get a big change in quantity demanded, what do we move here? Just look at the curve, we would move supply. So the increase in supply is going to cause a bigger effect than any of the other things. All right, so when the price of gas is $3 per gallon, Ben buys 11 gallons per day. When the price of gas falls to $2.50, Ben purchases 11 gallons per day. If we compute my price elasticity of demand on the basis of these data, what do we learn? Well, first off, my demand is perfectly inelastic because my quantity didn't change in response to the price. So my elasticity would be 0. As a result of having perfectly inelastic demand, we know that I'm going to bear the entire tax burden. And so it's got to be D. I'm going to bear the entire tax burden of any per unit tax placed on my individual purchase of gasoline. Okay, so suppose prior to allowing trade, the domestic price of maple syrup in Canada was below the world price. This tells us Canada holds a comparative advantage and should be an exporter. In the United States, the domestic price is above the world price, so the U.S. lacks a comparative advantage in maple syrup and should import. As a result of allowing trade to occur, what happens relative to the pre-trade equilibrium? Well, let's look at what happens in exports. For the exporting country, producer surplus rises, consumer surplus falls. Producers gain because now they find foreign buyers. Consumers lose because they lose their products to those foreign buyers. What about for the importing country? Producer surplus falls because now they're facing foreign competition. Consumer surplus rises because now consumers have access to cheaper products. This is consistent with B. Consumers or Canadians producing maple syrup are better off. Producers are better off, right? They're the exporting country. Producer surplus rises. Those in the United States consuming maple syrup are better off, right? This is the importing country. Consumer surplus rises. Employment in the U.S. maple syrup industry decreases. Well, producer surplus fell in the importing country. So that's what happens there. Which of the following are externalities? Ben decides to drive to Wisconsin overnight. It's very tired the next day. That actually happened for Monday. This is a direct harm to me, right? This is not an externality because this is something that, this is primary activity is me driving to Wisconsin, and the negative external effect is being tired. If I hire a contractor to finish my basement, as a result, I have to drive around a dumpster placed in my driveway. So we have the primary activity is hiring a contractor. The contractor decides to place the dumpster in my driveway. Now we have to drive around it, and so this is a negative external effect. I'm the bystander relative to the decision to complete the basement. The park near my house hosts weddings, and I can hear music on any given summer weekend. Yes, that's an externality, right? So there's a positive externality associated with that market behavior. Okay, because public goods are non-excludable, people have an incentive to be free riders. This is just our definition of the benefit, or definition of free riding problem, right? Being able to benefit from the good without paying for it. So 14C. Tragedy of the commons occurs because social and private incentives differ. This is another one by definition. The individual gains, but society loses when each acts on their own interest. Right? This is our tragedy of the commons, is that individuals have an incentive to act in their own interest, but this goes against the social, it's a social dilemma because it goes against what's good for society because of this negative consumption externality. So social incentives and private incentives differ. Some goods could be common resources or public goods depending on whether the good is rival in consumption or, whether the good's rival in consumption. I don't know what I was doing. So think about congestion here. If there's congestion, this creates this rivalry externality. And so that can make us go between a common resource or a public good. So if you're thinking about like a public beach, think about a public beach that's uncrowded. Now it's non-rivalrous. I go onto the beach and I don't really diminish how much space remains for other people. But if it becomes crowded, then you add an additional person, and one person's presence certainly diminishes how much space is available once the space constraint becomes binding. And so congestion can make the good go from a public good to a common resource. Beach house in Florida, it's rival, right? So one person's in the beach house, somebody else can't be. It's excludable. You have to own it or rent it. So it's definitely a private good. When externalities exist, buyers and sellers, well, they neglect the external effect of their actions, and the market equilibrium is not efficient. This is just true by definition. That's what externalities do, right? The external effect on bystanders is not salient, and it's difficult to quantify, so you just neglect those external effects. And then the market equilibrium that we get is going to be inefficient relative to what would be the socially efficient outcome that takes into consideration those issues. Okay, so short answers. The first one, suppose we observe there's fewer people eating avocados with their lunches on campus during winter 2019 than during fall 2018. Two analysts offer different explanations for the cause of the reduction in avocado consumption. So Diana's telling us a demand story. So maybe there's fewer people eating avocados because people just aren't interested because it's a summer food. So this would give us a decrease in demand for avocados. That would certainly cause a decrease in quantity. Okay. Sarah argues a supply story. Now avocados are out of season. So we expect that there's going to be a decrease in supply, and that's also going to lead to a decrease in quantity. Both Analyst 1 and Analyst 2 are perfectly consistent with observing fewer avocados on campus. Let's draw these pictures. We'll use the big small method, and I'll draw the picture consistent with Diana's story. So I'll draw the primary effect is a decrease in demand. So I'll draw a massive decrease in demand, small decrease in supply. In picture 2, I'll draw a large decrease in supply, small decrease in demand. This is going to capture Sarah's story. Okay, if demand shifts in both pictures, right? Demand and supply both decrease. It's just like the difference in the relative size of the shifts. If demand decreases more than supply decreases, quantity falls, but price falls. If supply decreases more than demand decreases, quantity falls, but price increases. So how do we know which is the most descriptive of reality? Find out what actually happens to price. And so here, to get full credit, you've got to say, not only have the graphs and be able to do this and say what's happening, price falls here, quantity falls, price rises here, quantity falls here, but to be able to distinguish between whether Diana or Sarah is correct, what do? We have to collect information on what's happened to the market price of avocados. If the market price of avocados has risen, then we'd say Sarah's probably correct. It's been a supply decrease story. But if the market price of avocados has decreased, then Diana's probably correct. There's been a loss of interest in avocados. Okay, governments often levy taxes on goods thought to be luxury items to generate additional resources or revenue. Consider the market for movie theater tickets. So, okay, in the absence of the tax, what's the equilibrium price and quantity? So here we're just looking for where supply crosses demand. The quantity is 6, the price is 7. What's the total amount of money received by movie theaters on the sale of movie tickets? Well, the total revenue for the movie theaters is going to be 6 times 7, right? The price is 7, the quantity is 6. And so their total revenue is this red rectangle. That's not producer surplus, right? Producer surplus is revenue minus costs. What's the seller's costs? Well, it's represented by the height of the supply curve. So if you're calculating producer surplus, it'd be 7 minus 1, so it'd be 6, times the 6 units, so that's 36, divided by 2 is 18. So you'd have like 18,000 or whatever would be these are in thousands. Yep, so 18,000 would be producer surplus, but total revenue is going to be 42,000. Oh, you got to be kidding me. Sorry about that. Right. So we got to illustrate the revenue rectangle. I've got this here. All right, so suppose the government imposes $2 per ticket on movie theater tickets, and the statutory burden is on sellers. What do we need to do to illustrate this? We need to leftward shift supply by the amount of the tax. So everywhere it's got to be $2 higher. So you notice everywhere I've got my supply curve with the tax $2 higher. This means that our tax-inclusive supply crosses the original demand right here. So the price paid by buyers will be $8. The price retained by sellers is going to be $6, right? Buyers are going to take $8 out of their wallet, 2 of which go to the government. Sellers keep $6, which covers their cost of producing the quantity we get, which will be 5 units. So that was just this. What's the post-tax paid by consumers? $8. What's the post-tax price received by producers? $2 less, $6. What was the quantity? 5. How much are consumers spending? $8 times the 5 units that they're buying, so 40,000. What's the after-tax revenue the movie theaters receive? Well, the sellers are going to get 6 times 5, or 30,000, because we're talking about in thousands. How much tax revenue would this generate? The government is going to get the difference. So buyers are paying 40, sellers are getting 30, so the government's getting 10. So you could do this two ways. You could say the government gets the difference between how much is leaving buyers' wallets minus how much sellers are getting, which is 10 or 10,000, or the government gets $2 per the quantity of 5 sold, or 5,000. This is in thousands, so 10. Show the area of the tax revenue on the graph. Well, that's just going to be this rectangle that I've shaded in purple. So it's going to be the size of the tax over the units sold. So $2 over 5 units, or 5,000 units. So it's going to be this area as tax revenue. Deadweight loss would be these two triangles together. This is corresponding to this 1 unit, or 1,000 movie tickets that are no longer bought or sold. Okay. So how's the economic burden of this tax allocated? It's 50-50. They share it equally. So the economic burden, statutory burden's on sellers, but the economic burden is driven by elasticity. Both of these curves have the same slope and absolute value, and so they're going to share the burden of the tax. Buyers actually literally pay $1, and sellers pay $1 of each unit sold. So that covers our $2 for the tax. Buyers are going to pay 50%, actually 5,000, and sellers pay 5,000 to give us the 10,000. How do we know how much buyers pay? It's the difference between the price paid by buyers and what would have been the equilibrium price, and the equilibrium price and the price sellers actually receive is the price how much sellers are paying. Okay, so during a power outage, my neighbor decided to operate a very noisy gas-powered generator to provide electricity. The generator's so loud, kids were not able to sleep, difficult to talk. Yeah. Model the situation, use a supply-demand diagram. Here, this is a negative externality, right? So you got to draw marginal private cost, marginal private benefit. Then the marginal social cost is going to be including the size of the negative externality. I actually should have labeled the externality as the distance between the curves here, or the distance right here is the size of the negative externality. The market equilibrium is going to be Q star. That's what happens if the decision makers ignore the externality. The socially efficient outcome is right here. This is what happens if the decision makers pay attention to the externality. So the socially efficient outcome would be here. The amount of generator use, it's too large relative to the social optimum. We get overproduction. So we could help the decision maker internalize the externality by charging a tax per unit of use equal to the size of the externality, but that wasn't part of the question. Here I'm just literally looking for this graph. Okay, so the U.S. imposes tariffs on a number of goods. Use the graph to illustrate the impact of a tariff, label axes, and so on and so forth. Label imports and exports. All right, so here's my price axis on the vertical, quantity is on the horizontal. Here's my domestic demand, here's my domestic supply. I've drawn in a generic world price. This tells us, because the world price is below the equilibrium, this tells us that there is the rest of the world has a comparative advantage. We lack a comparative advantage, so we can benefit from importing. Then I add the tariff. The goal of the tariff is to bring the total price that you're going to pay for. I have no idea what that is. We have the tariff price is going to bring the world price closer to the domestic equilibrium price. This is going to benefit domestic sellers. So I'm going to draw the tariff inclusive world price higher. Consumers in this economy are going to be able to buy whatever is this good at that price. The first couple units going up to QS at the world price with the tariff are going to be purchased domestically. And then the remaining units going up to the quantity demanded at the price with the tariff is going to go up to here, right? Size of the imports, it's going to be the difference between QD, the quantity demanded at the tariff-inclusive world price, and the quantity supplied at the tariff-inclusive world price. Consumers are actually going to buy this quantity, QD, at the tariff-inclusive world price. The first QS units or whatever are going to be produced domestically, right? Because the domestic supply curve lies below the world supply curve. Domestic costs are lower than world cost up to this price. And then these units are going to be imported. Okay. Relative to the free trade scenario, what impacts do they have? Well, total surplus falls. This is a situation where the losers lose more than the winners win. What happens to economic surplus? What happens to government revenue? Government revenue is going to be this rectangle. It's going to be size of the tariff, right? The size of the tariff is right here. Here was the world price without the tariff. Here's the world price with the tariff. The tariff is a tax on imports only, so it's going to be applied to the units that are imported. That's going to be our tariff revenue. Okay, so that's the end of walking through the exam practice. Now I've got two examples that I'm gonna pose for further discussion. So the first one, have a look at this. This was my gas station. So it says pumpkin spice coffee, $12 per ounce, or $12 for 12 ounces is $1.09. And look at this picture. This is supposed to be like this isn't just like pumpkin spice coffee. This is like supposed to rival the pumpkin spice latte at Starbucks. So my question is, think about this market, think about the market for pumpkin spice coffee, and think about like what impact, if any, this is going to have on competition with Starbucks. How Starbucks is going to respond, and how do you think consumers are going to respond? So think about like consumer elasticity, price elasticity of demand. Think about substitutes, and so on and so forth. Here's another example. So I went to the Economic History Association in Atlanta, and in the hotel in the West End, they had this collection of snacks. Cool. So let's look at the prices. So the prices, satisfy any craving with our signature collection of snacks and beverages. Signature collection, right? These are like things you could buy from a vending machine, but whatever. Snacks are going to be M&Ms for $4, Pringles for $6, beverages, water for $6, Coca-Cola, the can, 12-ounce can for $6, for $4, Diet Coke for $4, and then this wine bottle for $12. Okay, so the question is like, what's explaining these prices? Think about this relative to costs. Think about this relative to costs for the hotel and costs for consumers. Think about opportunity cost, and think about what's going going into this situation. You could also think of like application of elasticity, and thinking about like who's going to buy, like under what circumstances are you going to buy these snacks, and that can kind of guide us towards the intuition to like the basic question, which is like, what's the interesting economics behind this pricing policy? So, okay, go ahead and conclude here.